this is a really short one. I want to talk just basically about elasticity of material. Okay, when we're talking about material constants for elasticity, we'll look at phi tall. All right, we've already seen a couple, right? Talked about Young's modulus, E. We talked about Poisson's ratio, U. We also talked about the shear modulus, G. Those all govern the elastic response. Now, as it turns out, you have an isotropic material. In other words, that means there's no preferred direction for the material. So most of the times, you'll see materials are assumed to be isotropic. So a piece of metal basically is we pull on the toothbrush, you get the same response, regardless of which direction you try to apply it. Stiffness in all directions. If I pull this direction, same Young's modulus, if I pull this direction, right? There's no preferred direction. If I pull in this direction, right? You get the same Young's modulus, right? That's an isotropic material. A lot of times that's the case. You will see there's a good number of energy materials that aren't isotropic. I talked about wood. Wood has a different stiffness in the grain than across the grain. There's a lot of classes of composite materials. You've seen these where they're pretty common now. Take very strong fibers, embed them in a matrix of material, get different responses in actually all three directions. You get different Young's modulus. But if you have an isotropic material, which is what we're going to be dealing with in this entire class, you can show from thermodynamics and from symmetry that there are only two independent elastic constants, the constants of elasticity. I always have a tough time speaking and writing. Okay. So here I have three. In fact, there's only two that are independent. So there's a relationship between those three particular given. Here it is. The shear modulus is related to Young's modulus, Poisson's ratio. As follows. So if you're giving Young's modulus and Poisson's ratio, shear modulus, or shear modulus, Young's modulus, Poisson's ratio, Poisson's ratio and shear modulus, Young's modulus. Okay? And in fact, there's a whole slew of material constants for elasticity. There's lots of different names for them. Bulk modulus. There are constants called the Rame constants. And again, two of them, you can determine all of them, right? Once you define two material constants for elasticity, for isotropic elasticity, now you all know. So there. Okay. I'll organize that. So let's look at this. So what we have here is we have actually 5 different material constants. We have those modules, Poisson's ratio, T times C.